So now we are coming to the more tricky part of the applications of friction, which will be more in line with the JEE advanced type of questions. We're done with the basics of frictions in the last 3 lectures and the type of questions which you can typically expect at the JEE mains level. So we will start with an interesting question today, which involves not only the concepts of friction, but a little bit of the concepts of maxima minima. So we have a situation like this, that on a rough surface, which has a coefficient of friction as 0.75, or that's the same thing as 3/4, we placed a block of mass m, okay, which is at rest initially. Now we want to move the block, and to move it, we are free to apply an external force in any direction we please. So the force need not be horizontal; it can be at any angle of convenience with respect to the horizontal. So we have to find, first of all, that in order is at rest on a rough horizontal surface. Okay, as shown. Now we want to find the angle theta at which an external force should be applied. Such that the minimum magnitude of force is required to move the block. Okay. And secondly, we want to find the value of this minimum magnitude of force in newtons. Okay. Take G as 10 meters per second square for that. Okay, so take down the question first. I will explain what exactly has to be done over here. No, yes, this is not correct. There, the force we were applying was a horizontal force. Okay, in the previous lecture, we did a question where you are applying the force horizontally. But here, you can apply the force in any direction you like. So the first thing you have to understand is when you make the free body diagram, from the free body diagram of the block, you will see that normal reaction is affected by the F sine theta component. Okay. Therefore, maximum friction, which is mu n, is a function of theta. Okay. Therefore, minimum force needed to move the block, which will be mu n, will be a function of theta. Okay. So you express it as a function of theta and then minimize the function. That maximum minima concept, use it to minimize the function. So just try this out now. Yeah, so actually, yes, you're correct. We have done this question in the last lecture. I just checked the notes. We have done this question in the last lecture, so you should know how to do this. You've done a similar question, so try to work it out yourself now. So you should be able to tell the answer pretty quickly now. Okay. Just recall the steps. Last time we have discussed extensively about simple force and application of continuing movement of the laws of motion today. Last time we have discussed extensively about simple force and application of the concept of Okay, so let's see. This should be able to. Yeah, the angle will be 37. That's correct. Okay. So in the free body diagram, you have f cos theta like this. You have f sin theta like this. You have normal reaction, weight, and friction. Okay. So f cos theta should be greater than equal to friction. I mean maximum friction to for the block to move. Okay. So n you can see will be equal to mg minus f sin theta. So when you substitute this here, you can see that you will get f cos theta should be greater than equal to. So for the minimum force to move the block at some general angle theta, you will get f equal to mu mg upon cos theta plus mu sin theta, this function. So next thing, remember we had written this function as square root of 1 plus mu square into sin theta plus alpha. That was a trick. Okay. So we saw that f minimum will become mu mg upon square root of 1 plus mu square. But that will be when sine of theta plus alpha is 90 degrees, or theta is equal to tan inverse mu, or theta in this case is tan inverse of 3 by 4 or 37 degrees. Okay, so the minimum, so this is the first part's answer you will get. The second part's answer, the minimum value of force will become this thing. 3 by 4 upon square root of 1 plus 9 by 16. So that will become 3 by 5 mg, or in this case 60 newtons. So this has just become a repeat or revision of the question we had done in the previous lecture. Okay. You should have been able to get this, all of you. Minimum force of 60 newtons can be used, but for that the angle has to be 37 degrees. Okay. So anyway, if you're not clear with this, make sure to revise from the previous lecture. Okay. Now we'll move on to some more questions. So in fact, today we'll be doing some questions from H.C. Verma. So next up, we'll pick up examples and doubts from H.C. Verma. So you can start sending me the text message with any questions that you are stuck with in H.C. Verma friction chapter. Yeah, Chris, that is there in the previous lecture notes, so you don't need to copy again. Just if you have any doubts in the first 15 questions of H.C. Verma, send it to me in friction. I will discuss. Yes, today will be the last lecture for friction. And Newton's laws of motion we have already finished. This is the second part of Newton's laws actually, which is friction. Okay. So I'm starting with question number 10 from H.C. Verma. If you have any doubt before question number 10, then please discuss with me or send it to me as a text. This is in fact session number 5. Okay. Missed out session number 4. That's so what's happening in this particular question is that is given to you that the angle made by the net contact force and the normal reaction force. Okay, this angle they are giving the symbol lambda, and it is called angle of friction. So that is what is given in the question. So we have to prove that lambda cannot exceed tan inverse mu, where mu is the coefficient of friction. It is the coefficient of static friction. So it's a very simple situation really. You'll understand that whether you are talking about a block on a horizontal surface or a block on an inclined surface, whether there are some external forces acting or not, whatever be the case, normal reaction, and if the tendency to slip is towards the right, okay, then friction will act like this. Here the tendency to slip is down the inclined plane, then normal reaction is like this, but friction is like this. So the important thing is that normal reaction is always perpendicular to friction, and the net contact force that they are talking about now, this thing, this is the resultant of friction and normal reaction. Okay. So therefore the net contact force, let's call this R, this is the resultant of friction and normal reaction. Okay. This net contact force is the resultant sum of normal reaction and friction, both of which are contact forces. So this will always be such that it is square root of n square plus f square. Okay, because they are perpendicular to each other, because of this. Okay, So now using this, you should be able to figure out this proof very easily. Just try to complete it with a vector diagram now. So in the vector diagram, try to understand which is the angle lambda that they're talking about, which is the angle of friction. Okay. Normal reaction and friction act perpendicular to each other, and the angle made by the resultant or the net sum of normal reaction and friction with respect to normal reaction, that angle is lambda. So how will you prove from that now that lambda should be less than equal to tan mu? That is what we have to do in this question. So try this out now, please. Yeah, student, sorry, there was disruption in my internet service. So anyway, let's come back to this question. So whether you're looking at this vector diagram here or you're looking at this one, the relationship between the normal reaction vector and the friction vector is that they are perpendicular to each other. So the resultant, okay, whether it's like this or it's like this in the case of the inclined plane, okay, the resultant sum of the two, that's this one, that's this diagonal of this rectangle kind of thing, and this is the angle lambda that they're talking about. So you can see that in this diagram or this whichever one, the magnitude of the resultant is root of n square plus f square, and tan lambda is f by n. So this is the one which is more important. So you can see that friction is less than equal to mu n. So that means r is less than equal to n square root 1 plus mu square, and from this tan lambda is less than equal to mu, or lambda is less than equal to tan inverse mu. So the angle of friction can never exceed tan inverse lambda, sorry, tan inverse mu, when mu is the coefficient of friction. So that was question number 10. Okay. Now next I am moving on to question number 12. Okay, so if anybody has a doubt before question 12, please drop me a message. 16 and 21, yes, I'm coming to that, Krish. So after 12, I will be doing question 16 next. So go through these questions, 12 and 16, we'll discuss. Okay, so 12th is a bit of a reverse question. The acceleration of the two blocks is given to you in the diagram, and the tension in the string is given to you. So you have to, from that you have to find the coefficients of friction for each of the blocks. So ultimately it has to be solved by free body diagram method. But when you write the equations, your unknowns will be coefficient of friction, whereas tension in the thread and normal reaction will be known quantities. Okay, so this angle is given to us as 30 degrees. Okay. This block B has a mass of 4 kgs. This block A has a mass of 2 kgs. And here the coefficient of friction is mu1. Here the coefficient of friction is mu2. It is given that acceleration of the blocks is 0.5 meters per second square, and the tension in the string is 16 newtons. So from that we have to find mu1 and mu2. Okay. So obviously this is coming down the inclined plane, this is moving like this, and now you can see the forces will be like this: tension, okay. Then for this one you can take the components of weights. So 4g cos 30 degrees, 4g sine 30 degrees. Okay. For this one 2g directly. Okay. Then we have the normal reactions, NB, NA, and finally the frictions. This will be mu2 NB, and this will be mu1 NA. So now you have to just write the relevant equations and substitute the value of tension and acceleration to find out the value of mu1 and mu2. So if you haven't done this question or tried this before, please work this out. Okay, so let's check the values. So this normal reaction will become this. Okay. So 4g sine 30 minus mu2 NB minus tension is equal to 4a. That is the equation for the block B. Okay. So this will become 2g minus mu2 into 2 root 3g minus 16 newtons is equal to 4 into 0.5. Okay. So 2g minus 16 minus 2 is equal to 2 root 3g into mu2. Now let's substitute g as 10. So this will become 20 minus 18 is equal to 20 root 3 mu2. So mu2 will become 2 by 20 root 3. So that will come out to be which is the answer they have given. Whereas for block A, you can see the equation is T minus mu1 Na is equal to 2A, okay, and Na is equal to 2G or 20 newtons. So 16 minus mu1 into 20 is equal to 2 into 0.5. So 20 mu1 is 16 minus 2, sorry, 16 minus 1. Okay, so mu1 is becoming 15 by 20 or 3 by 4 or 0.75. So these are the values. Okay, so note this down and come to question 16 next. Okay, we'll do some questions then. Anyway, so let's come to the 16th question, please. So in 16th question, what is happening is now when you apply hard brakes or jam on the brakes now while going down a slope, the tires will start skidding. That means the type of friction acting on the tires will be kinetic friction. Okay. So assuming that the tires are skidding, is what will happen. Okay. So you will see that even in that case, this is accelerating downwards, and that acceleration will be because mg sine theta is going to be more than the kinetic friction. Okay. So this will have an acceleration of g sine theta minus mu cos theta. So that when you work out in this particular question, that will come out to be 1 by 2 minus mu is given to us as 1 by 2 root 3, okay, into cos 30, which is root 3 by 2. So this will come out to be 2.5 meters per second square. This is what the acceleration will come out to be. So when it started from the top of the slope at certain speed and at the bottom of the slope, it has certain speed. So use this relation v square is equal to u square plus s is given to you. The slope length is 12.8 meters. Okay. U is 21.6 kilometers per hour. So convert that into meters per second and then substitute all this information here. So you'll get the V. Okay, so hope this is clear. Okay, so it's a case of simple kinematics from this point. But you just apply the free body diagram method to find the acceleration, the uniform acceleration. Apply V square is equal to U square plus 2AS. Okay. So the question is saying no matter how hard the brakes are applied, the speed will be greater than this. Means that even when the brakes are jammed completely, so there is kinetic friction acting, even then you will get this certain value of V. Whereas if the friction is less than this, the value of V will be more than, the speed will be more than the value of V we are getting from here. So that's what the meaning of the question is. No, in this case, the friction coefficient is not enough for retardation. Understanding the point, Krish? So in real life, what happens is that the tire is designed in such a way with the material of rubber having a larger coefficient of friction. Only then it is possible to decelerate while going down the slope. For this kind of coefficient of friction, which is quite less, now you can see it is 1 by 2 root 3. So it is something in the region of about is something in the region of probably 0.27 or something. So it's quite a less amount of friction. So this is not a real life application. In the case of the actual tires, the rubber, the material is such that the coefficient of friction is much more. So in that case, the frictional force can exceed the mg sine theta component. Okay. And the other thing is in real life, 30 degrees is a very steep incline. The typical kind of inclines that you see now for roads and all that is much less. It is less than 15 degrees, less than 10 degrees even. So the likelihood of this thing happening, that you are jamming on the brakes and still your car is accelerating downwards, is not there. That doesn't really happen in real life because of two things: because the angle of inclination will be less and the coefficient of friction will be more. Okay, so hope that is clear, Krish. Okay, now we'll move on to the next doubt you've asked, which is question 21. Okay. What about question 18? Have you solved question number 18? I think we have discussed something similar in the class, but just go through question 18. If anybody has a doubt in it, you can discuss with me. Otherwise, we'll solve question 21 next. Okay. Just check if you are clear with question 18 once. Question 20 is something that we just did, that angle wala question where we have to find the minimum force. That is the same as that question 20 actually. Yeah, I think you've done. So you should be able to do question 20. Sorry, question 18 and 20 also. So let's move on to question 21. So just make the free body diagram of the person and the platform, and the rest will be easy. Okay, so the person's mass is given to you as capital M. The platform's mass is given as small m. And the ground below has a coefficient of friction mu. Now you have to find the maximum force with which the man can pull the rope with such that the platform does not slip. Okay. So you'll understand that whatever force he pulls the rope with downwards, that becomes the tension in the rope. Massless rope, so uniform tension. So F is equal to T. That's our first equation. Okay. And then, of course, you make the free body diagrams and you'll understand the rest. So for the person, there is tension acting upwards, his own weight, capital Mg acting downwards, and normal reaction that the platform is applying on it, that's let's say N1. So T plus N1 is equal to capital Mg. That's our second equation. Okay. Now for the platform, on the other hand, the forces acting are this normal reaction that the person is applying on it. Okay. The platform's own weight, small mg, the normal reaction the ground is applying, and now this is getting pulled from this side with tension. So static friction is preventing it from slipping, assuming no slipping. Okay. So it does not slip, so acceleration is zero. Okay. So T is equal to static friction for no acceleration, and N2 is equal to N1 plus small mg. That's our fourth equation. Okay, now in this we have to understand that static friction cannot exceed mu N2. Okay, so substitute. So static friction required is how much tension, and that should not exceed this. Okay, and then substitute N1 from here in this. So you'll get the required relation. So the required relation now is that T should be less than equal to mu N1, and N1 is capital Mg minus T. Okay, plus small mg. So expanding this, you'll get 1 plus mu into T is less than equal to mu into small m plus capital Mg. So tension should not exceed this value. Okay. And tension is the same thing as force. So from this, you'll see that force should be less than equal to so this should be, so the maximum will be the equality symbol. Maximum force you can apply so that the system is not slipping. This. Okay. So just make a note of this, people. And yes, I will take you back to question 18 after this. Just make a note of this first. Yeah, Chris, you can do that also. You can take the man plus the platform as a system, and then the external forces will become like this. If you take the man plus platform, because they're both at rest, na? So it's one object. So then the external forces are tension, okay, combined with, okay, this normal reaction from the ground, again tension from here and friction. So tension is equal to static friction. Okay. Tension plus N2 is equal to M plus mg. Okay. And static friction should not exceed mu N2. So from equation 1 you substitute this here, and from equation 2 you substitute N2 here. So you'll get tension should be less than equal to. It's the same thing basically. So F is equal to T, so that's one and the same. All right, so that's that. Now for 18th question, since Yash has asked, we will discuss the basic concept and you can solve it yourself. So see, in 18th question, what we can do is, Acha, you got it, very good. Okay, then what we will do is, since you people have not solved further in HC Verma, we will do some other practice questions. Okay, so we have a system like this now. So basically, we'll just do a bit of application of system of pulleys along with friction now. So mass of A is given to us as 20 kilograms and coefficient of friction is 0.5. Okay. So in the first part, find the maximum value of mass of B such that A will not slip. Okay. In fact, take the coefficient of friction here to be 0.6. Easier to calculate. Okay. Second, if mass of B is equal to 5 kilograms, then find the friction acting on A and acceleration of A and acceleration of B. So again, find friction. And their accelerations. So try out this question, please, people. Yeah, the first part, the answer is correct, people. 36 kgs is the correct answer. First part, the answer should be 36 kgs. Okay, so let's see. So for the first part, you want that the system should be in equilibrium. So the condition for equilibrium will be that the net force on the block B is 0, which means that if the tension in this thread is T, Yeah, people. So let's understand this question. So when we are solving for the equilibrium condition, you will see that for the block A, this should be less than equal to coefficient of friction, which was given to us as 0.6, okay, into normal reaction was weight. Okay, so that's 200 newtons. So maximum static friction is 120 newtons. So that will apply over here. But also now for block B, you can see that the condition for equilibrium is that 3T is equal to weight of B. Okay. So now connect these two equations, and that will tell you that 1/3 of the weight of B is equal to the static friction. And this is showing you that static friction is less than 120 newtons, less than equal to. So 1/3 of B's weight should be less than equal to 120. So that means B's weight should be less than equal to 360, or this is the, for equilibrium. So now you can see the both the cases that I've given you after this, they are of equilibrium condition only. Because in the second part, I've taken mass of B as how much? So 5 kg, and third part is 1 kg. Okay. So this will be equilibrium case. Okay. Tension will become 50 by 3, because 3T is equal to weight. Okay. So static friction acting on A will be equal to tension. So it's 50 by 3, or 16.67 newtons. Okay. And in the last case also that I've given you, it's more or less the same kind of situation. Just the value is different. So this is also the equilibrium case. Okay. So tension in this case will be 10 by 3 newtons. Okay. So friction will also be 10 by 3, or 3.33 newtons. Okay. Now let's take one case where there is acceleration involved. Okay. So add one fourth part to it. Add a fourth part where we take the mass of B to be something larger. Let's take it to be 50 kgs, or divisible by 3. So let's take it as 45 kgs. Okay. So find out the friction and the acceleration of A and B. So just work this out, people. Okay, so after you finish writing down the first, second, and third part, this is the first part, this is the situation for the second, this is the third. Just work out this fourth part now. Just give you the data in case. No, 45 kgs. Na? So now the system will involve slipping. So the friction will be which type of friction? It will be kinetic friction. Na? So it will be 120 newtons of friction. Okay. So the moment you are making the block's mass, B's mass more than 36 kg, okay, the system has to involve slipping. So let's take that into account. And when this system involves slipping, okay, for that situation, what kind of constraint relation will be there? The acceleration of A and B will have a certain ratio. No? That will be 3:1 ratio. Okay. So when we take mass of B as 45 kg, this will now involve acceleration. So this has some acceleration AB, let's say. This has some acceleration A. Now you can see that the constraint relation on these three tensions are acting. On that, a single tension is acting. Okay, so you can see that acceleration of A will become 3 times acceleration of B. This you'll understand from constraint relation thread length conservation. Okay. Here there will be kinetic friction acting, which is mu Na. Okay. So for B, your equation will become weight minus 3T is equal to mass into acceleration. So this will become 450 minus 3T is 45 into AB. That's our second equation. Okay. And for the block A, we'll have tension minus kinetic friction is equal to mass into acceleration. So that is tension minus mu Na. Is this okay? Or tension minus is this okay? So tension minus 120 is equal to 20A. So writing this wrong. Okay. So that is my third equation. So is this clear so far? Okay. Yeah, friction will be this. Now we have to just substitute. So substitute this thing here. So this becomes T minus 120 is equal to 60 times AB. Okay. And then multiply this equation by 3. So this becomes 3T minus 360 is 180 times acceleration of B. Okay. Now compare with this equation. So 450 minus 3T is equal to 45 times acceleration of B. Now you can add these two equations. That will give you the required acceleration. So 450 minus 360 is 45 plus 180 times acceleration of B. So 90 will become equal to, now here we can take 45 common, so 1 plus 4 times acceleration of B. So acceleration of B will become 2 by 5 or 0.4 meters per second square, and acceleration of A will be 3 times AB. So 1.2 meters per second square. Yeah. So these are your final answers. So especially for your JEE advanced level, you should be able to connect the concepts. Thread length conservation, constraint relation, which you've learned in the previous chapter, Newton's laws of motion. Now that is being added to the concept of friction over here. So that is the main, important aspect of the JEE advanced level questions, that you are able to connect the concepts from different chapters together and so on. Okay, so hope this is clear and understood. Now let's look at another question. So again, similar to a question we've seen before, you have a rough wall against which you placed a block. So this has a coefficient of friction of 0.25, and this block has a mass of, let's say, 4 kg. I'll make it 5 kg. Okay. But the difference is this time we are applying the external force, not horizontally, but like this. We are applying an external force like this at an angle theta. So find the acceleration of the block, if any, okay, and the friction acting on it. If A part, we take the value of the force as 250 newtons, and we take the angle theta which is shown as 53 degrees. Okay. And the B part, we take the value of the force So I'll give you the B part. Just start with this. 100 Newton, then theta is equal to 37 degrees. So just try this question out, people. Okay, let's understand what's happening in the first part. So 250 newtons and 53 degrees. Mass of this is 5 kg. So you are applying this force 250 newtons where this angle is 53 degrees. So that means this angle is 53 degrees. So when you resolve that force, you'll see that it has a x component of F sine 53. So that's 200 newtons. Okay. And it has a y component of F cos 53. So that is 150 newtons. Okay. Then of course this has a weight of 50 newtons. Okay. So this develops a normal reaction. Okay. And now you can see this is dominating over this. So the tendency is to slip upwards. So friction will tend to act like this. Okay. So you can see that the normal reaction will balance the x component of this force. So it will be 200 newtons. So from this you can see that the maximum static friction mu n. So we've taken the coefficient of friction about to be how much? 0.25. So that's 1/4 of this. So that's exactly 50 newtons. Okay. So now you can see that Fy minus mg, that is how much? 150 minus 50. So that's 100. Whereas the maximum friction is only 50. So Fy minus mg, which is the tangential force, is greater than maximum friction. That means slipping will take place. Okay. So if slipping is taking place here, it will accelerate like this upwards, and this will be kinetic friction. So Fy minus mg minus kinetic friction will be equal to me, and the E will be upwards. Okay. So Fy minus mg minus mu n will be me. So there we go. 150 minus 50 minus the maximum friction was 50. Okay, that should be equal to mass of the object, which is 5 into k. So we will get E as 10 meters per second square, quite a large acceleration equal to g, but in the upward direction. So this was the first part, when the force was 250 newtons and it was at theta equal to 53 degrees. Now we'll work out the second part where the force is 100 newtons only, but the angle at which it is acting is 37 degrees to the vertical. So hope this is clear to all of you. Excuse me. So Krish, your answer for the first part is correct. Very good. Hope you got the same free body diagram and friction and everything. Okay, so let's wind up the second part. So in this now we are applying the force of 100 newtons at this angle of 37. So the x component of the force will become 60 newtons. Okay, that will be F cos 53 or sin 37, whereas the y component of the force will become 80, that is F cos 37 or sin 53, whatever. So that will create a normal reaction which will be of 60 newtons. Okay. And mg was 50. So again this one dominates. So friction will tend to act down. So now from this you can see that the maximum friction will be only 15 newtons. So the coefficient of friction was 0.25. So now you can see that again Fy minus mg is 30 newtons, and that is greater than maximum friction. So there is acceleration upwards. So it's a similar situation, only the value of acceleration will be different. So Fy minus mg minus kinetic friction will become ma. So Fy minus mg minus mu n Vma. So now just substitute the values. So 80 minus 50 minus 15 is equal to 5a. So we get an acceleration of 3 meters per second square upwards. Okay, so make a note of this, please, people. And with that, we conclude today's session. We'll continue from this point on Sunday. So please complete HC Verma the remaining few questions so that you can discuss the doubts with me on Sunday. And we will be starting with the next chapter of work by energy on Sunday itself. So we'll keep about half the lecture for doubts and half the lecture for starting with work by energy. So thanks for attending. That's it for today's session, people.